My name is Steve Kenniston. I am the Business Development Executive for Spectrum Storage Software, and I'd like to take a few moments of your time to talk to you about how IBM has enhanced its modern data protection portfolio to enable the protection of containers. Let's begin. First, I do believe that by now all of us realize that a hybrid multi-cloud is the new normal for most all data centers. 94% of enterprises today have hybrid cloud models, mixing public, private, dedicated, and countless SaaS applications. This trend will continue with the rapid growth of all three flavors of cloud through 2020. 67% are using a mix of multiple cloud vendors, each with their own proprietary tools and management systems. All this while enterprises continue to make significant investments in traditional IT. This new hybrid multi-cloud reality creates not only opportunities, but also new challenges for IT leaders. 82% are concerned with how they will connect all of these clouds and traditional IT. 73% need better ways to move apps, workloads, and data between these clouds more effectively. 67% worry about how they will manage this new mix of clouds and environments in a consistent way across vendors without introducing new security and compliance risks. Even for those looking to aggressively move more into the cloud, it will be a long journey. The question is, how can IBM help accelerate that journey? Now, Dilbert is a stereotypical-minded individual. Dilbert is capable but ignored at work and loves technology. The pointy-haired boss is Dilbert's boss. He is notable for micromanagement, gross incompetence, obliviousness to his surroundings, and unhelpful buzzword usage. Yet somehow he seems to retain his power in the workplace. He is hopelessly incompetent at management. He doesn't understand technical issues, but always tries to disguise this, usually by using buzzwords he really just doesn't understand. On this slide, you will see a list of terminology that I will be using during this presentation that speaks to a number of the components that come up during conversations you may be having when it comes to container-based backup. Now, without reading each term and the definition to you, are there any questions about these terms that you would like me to review or go over? How many folks have actually heard of these terms before? Now in slide 2, we ask the question, how would you accelerate your journey to hybrid multi-cloud? The answer is by utilizing new capabilities called containers. IT is at an inflection point. Just as we were with virtual machines became new compute. Containers are the new compute. Containers offer an alternative to virtual machines and a new approach to virtualization. Containers are built around a virtual operating system versus a virtual server. Containers are widely used in cloud environments because they have a very small footprint and need minimal system services to make them very agile. It is also important to note that containers originally caught on for applications that were going to be stateless or not require any persistent storage. However, this is changing as they are beginning to form the underpinning of private clouds. The next topic to cover would be Kubernetes. You probably hear this term a lot when talking about containers. Kubernetes is an open source container orchestration management solution for automating container application deployment, scaling, and management. Kubernetes is the tool developer admins use to manage their containers. It is all command line and is the mechanism that all container and data management is done. This is where the backups are driven from. Another term you'll hear a lot is OpenShift. OpenShift is a family of containerization software developed by Red Hat. Its flagship product is the OpenShift container platform. This is what we speak most about and is built around Docker or cryo containers orchestrated and managed by Kubernetes. The primary IT initiatives that Red Hat OpenShift targets are as follows: accelerated application delivery with agile DevOps methodologies, modernize application architectures towards microservices, adopt a consistent platform for hybrid multi-cloud deployments. Now, the business value behind OpenShift is to provide IT staff productivity, business productivity, IT infrastructure cost reductions, as well as risk management and end-user productivity. A note to listeners. While it is important to understand the bold highlighted text in this presentation, it is too much to read to a client, and it's not germane to the topic for backup for containers, but it'll help you be prepared for the answers to the questions, as well as provide some anecdotal information during a presentation. The next chart explains the concept and terms about IBM storage for Red Hat OpenShift container platform. Containers are moving to a services-based model. Application developers using DevOps tools are leading the charge to help enterprises do continuous engineering and continuous integration. No application is ever complete. It is constantly morphing and changing, and based on market needs and client requirements. Containers provide developers the freedom to build and morph their applications quickly and easily. A common container platform is Docker. However, Red Hat uses cryo containers. Containers provide a way to put everything that your application needs into a small image that can run on any computer that also has cryo or Docker on it. This eliminates the problem of, hey, this program ran on my computer, but it doesn't work on yours. A container is not a virtual machine. As the diagram shows, in a VM, you have to package up an entire guest operating system into a virtual machine. You have to have the binaries and libraries that are required to run your application, plus you need your application installed on it as well. In a container environment, you don't need a guest operating system. The container does all the translation for you and doesn't take up a lot of space on your hard disk. Your application just run in a container, and the container has the definition of the binaries and the libraries it needs, as well as the actual application itself. In the container model, you can share binaries and libraries. So if you are running 3 applications, you don't need 3 copies of the libraries or binaries installed. Containers optimize the size of your IT infrastructure and help clients to save money. As clients started embracing containers, managing hundreds and sometimes thousands, or even like Google, billions of containers becomes an issue. Kubernetes is the most popular container orchestrator today and is what is used in the Red Hat OpenShift container platform. And container adoption is growing much faster than the adoption of virtual systems. Container adoption is happening 66% faster than virtual system adoption actually happened. Now, as we said before, the first instantiation of containers was their deployment without persistent storage. However, as containers became more widely used, there's become the need to have persistence associated with these containers. In fact, a Tech Validate survey of over 250 users cited that the biggest challenge with container adoption is the ability to have persistent storage. Today, containers are getting much better at handling persistent storage, especially with the advent of the CSI, Container Storage Interface, API in Kubernetes. The CSI API is very similar to VADP API in VMware. It talks to different storage arrays in a standard way to provide consistent set of storage services. Having the CSI API has enabled easier adoption of persistent storage for containers. There are many capabilities within CSI. One is stateful sets. Stateful sets automatically handle the hard problems of gracefully scaling and upgrading stateful applications and of preserving network identity across container restarts. Stateful sets provide a great foundation to build, automate, and operate highly available applications such as databases. The CSI API provides the ability to take snapshots of persistent storage, which becomes key when doing data protection of these environments. And wouldn't you know it, just like regular systems and applications, they too need to be backed up. And just like persistent storage is a challenge to containers, security, data loss, and DR are the top challenges users have when thinking about using containers. I think we can all admit protecting data is always a challenge no matter what you're trying to do. At IBM, we too recognize the history of these inflection points. It is during these inflection points there tends to be big shifts in infrastructure and what is required to support the new way in which compute drives data creation. More importantly, changes happen in how data that is created by these new compute methods are protected. It is important to share with you how IBM looks at the market by workload and how we invest our dollars in the data protection space to help our clients. First, we start with traditional workloads on bare metal servers. This is a place where IBM shines. IBM has been protecting these workloads for over 20 years, and you'd be hard to find a workload, operating system, or storage platform that we don't support. In addition, we know that there is a percentage of these workloads that will never go away and will continue to need robust data protection. The next phase was contemporary workloads. These are workloads that may perhaps seem more traditional these days, but are really based around virtualized systems. Now, the reality is that IBM was so focused on taking care of their many clients in the traditional workload space, we didn't really do a great job at jumping on the bandwagon of supporting data protection for virtualized workloads. However, with that said, over the course of the last 3 years, IBM has invested quite a bit at modernizing how we back up these virtual workloads and have a highly competitive solution in the marketplace that has a key modern set of capabilities such as ease of deployment, agentless protection, self-service, and RESTful APIs. And this is a bonus and is the foundation for the next workload evolution. Data protection as we move into Cloud 2.0 or next-gen workloads that tend to be containerized or born in the cloud. As we continue to invest in our data protection portfolio, we will be providing thought leadership with deep integration with Kubernetes, more robust data agility, and what we call AI-infused data protection to help our clients more intelligently protect and recover data. When it comes to protecting container workloads, the focus needs to be very similar to protecting traditional workloads. There needs to be a focus on the application. Applications need to be copied and moved to secure storage, and the protected copy must be crash consistent and application consistent, such that on recovery, these applications are ready to run. Also, just like in virtual environments, there needs to be some level of integration with the specific storage APIs to be able to execute the proper storage functions, in this instance, snapshots. And finally, just like virtual environments, integrating with solutions that manage the virtual machines, such as vCenter for VMware, integration with Kubernetes, the management of containers, is also crucial. It's even more important for container environments as more of the data management and protection is done through Kubernetes than traditional backup solutions. Now, foundationally, knowing what we know about containers and the requirements necessary for protecting them, we spent a great deal of time defining the requirements to have a proper data protection solution for containers. Based on our requirements gathering, we developed our solution with 3 key things in mind. First is the integration with Kubernetes and ensuring protection is Kubernetes aware and can be executed by the kubectl CLI. This is the Kubernetes command line interface. This makes the solution intuitive for the developers and how they like to protect their data and are able to execute backups, restores, and their SLAs simply and easily. Next, we needed to ensure we carried forward the self-service nature of what we do in the virtualized world to containers. As mentioned, it is the developers that are looking for protection for their containers, so providing them with the tools is very, very important. And finally, integration with the CSI driver that provides the storage services, such as snapshotting, was also very important. This way, as Kubernetes changes or a protection application changes, we are consistently writing to one standard API and can ensure nothing breaks as the environments evolve. As noted in the slide above and a few times during this presentation, when it comes to backing up containers, it is typically the container or Kubernetes administrator that wants to drive this protection. In this slide, we have two personas. We have Jane, the Kubernetes administrator that will be defining and executing the backups. We also have Jose, who is the backup administrator, and at the end of the day is responsible for ensuring that the data is protected across the company. Now, Jose will want and need to see through the usual backup interface that the corporation's containers are being protected, and this is shown in the data protection interface. Jane focuses on all aspects of container management, including protection, and her method of management is via the kubectl CLI. This is where the self-service nature of the IBM Data Protection solution is helpful, such that Jane can set up the services she needs for her environment, including the predefined SLAs for the containers, as well as have the ability to do ad hoc operations as needed. Container support for Kubernetes protects persistent data in Kubernetes environments. Highlights of the offering include the ability to provide the application developer with a self-service interface using the Kubernetes CLI. This enables simple and fast adoption for the developer based on using the interface they are familiar with. Use Container Storage Interface, the CSI, standard to initiate and persist snapshots for Kubernetes, persistent volume claims using Ceph block storage, provide periodic full copy offloads of PVC's snapshots to Spectrum Protect Plus vSnap repository to provide offload security, having a fault domain that provides resilient backup copies, enhanced Kubernetes-aware backup scheduling for automation, SLAs that provide control for scheduling snapshot retention and a copy to vSnap. The solution provides a great deal of value to all parties involved that include, as we mentioned, self-service, as well as automation, governance, and resilience. Jane, the developer, is able to leverage native tools and interfaces, making their job simple and easy, and Jose, the operations person, has a tool to monitor and report, as well as a tool that is fast to deploy with predefined SLAs. The overall solution provides the most robust means of protecting containers for all involved. It's very important to take the explanation of container-based backup a step further. The reality is, in a lot of cases, folks in IT don't necessarily know the process that the container or Kubernetes administrator need to go through in order to provide data protection for container environments. Their management tool is typically the Kubernetes CLI. As well as protection, the development team needs copies of production data in order to do the testing of their application development. This means they need self-service capabilities to provision storage or VPCs, assign data protection service levels that align to their corporate governance requirements, perform ad hoc backups to protect their data, and also have the ability to restore their persistent data for multiple use cases. Each of these needs helps to support a robust DevOps workflow and make the developer more efficient. It is also important to understand that each group, the infrastructure team and the application team, has their own way in which they speak when it comes to the implementation of any solution. Infrastructure speak lays out steps for implementing a solution. When it comes to the IBM Data Protection solution, step one would be to download and install the CSI drivers and install the SASE, the solution that connects Kubernetes to Spectrum Protect Plus. And SASE is a separate tar file from IBM that you download from our website. Connect Spectrum Protect Plus in Kubernetes, start managing and backing up your PVCs, and perform restores of your PVCs when necessary. The process is the same for Kubernetes administrators. They are just laid out with the term days, starting at day 0, where these days are not necessarily 24-hour periods. Keep in mind what audiences you are speaking to when explaining IBM's data protection solution. Now, when looking at the solution architecture, it looks like the picture shown. The information in the red dotted line box is the Kubernetes environment. You see the containers in Kubernetes stack, the applications, as well as the SASE interface and the data movers. It also shows the persistent storage. Outside that environment is the backup application, Spectrum Protect Plus, as well as the vSnap server where the backup data actually lives. IBM's data protection solution will be integrated tightly with OpenShift as the CSI interface is certified for OpenShift. Combine this with IBM's data protection solution, you will have the best data protection solution for your containers in any environment. The solution provides tight integration with Kubernetes, protect integration with persistent data using the CSI snapshots, the predefined SLAs, job monitoring in both the IBM data protection interface as well as the Kubernetes CLI. And a beta for data protection integration with OpenShift is available in Q4. If you want to test out the beta, you will need to ensure that you have the right environment that is made up of Kubernetes with OpenShift, OpenShift container storage, and the CSI interface for snapshots for persistent volumes. The key use cases in these environments are persistent storage snapshots in Ceph, the creation of periodic full copy snapshots to the vSnap repository, and Kubernetes-aware backup scheduling and automation. Now, as IBM moves forward, we will be adding application awareness for applications as well as providing even tighter integration with Kubernetes, including awareness for namespaces, labels, stateful sets, pods, and services, as well as different configuration objects and etcd files. In addition, the integration with OpenShift gets tighter with CSI and Cloud Paks. Also, as we move forward, we will have backup application, Spectrum Protect Plus, containerized, and this will enable a Kubernetes or OpenShift administrator to deploy IBM's data protection solution into a Kubernetes environment with no outside dependencies except for using the CSI for snapshots. The offload to vSnap outside a Kubernetes environment would be optimal. This has been identified by talking to clients as a very desirable option because some don't want to have environmental dependencies outside of their control. In addition, there will be more services that roll up to the Spectrum Protect Plus interface and will provide a richer set of reporting and data reuse use cases. At the heart of the full stack architecture are IBM Cloud Paks. These are an open, faster, and more reliable way to build, move, and manage in the cloud. Cloud Paks provide the industry's richest catalog of IBM and open source software containers and feature runtimes and orchestration capabilities for automation deployment with enterprise-grade configurations. The IBM Cloud Paks run on top of a Kubernetes-based orchestration platform that enables high availability, scalability, and ongoing maintenance for enterprise applications from a source you know and trust. The software solution runs on the client's choice of infrastructure, including IBM Power Systems, IBM Spectrum Virtualize, IBM Spectrum Scale, IBM Cloud Object Storage, and supported by IBM Spectrum Protect Plus for data protection. Soon, IBM's data protection solution will be embedded into the IBM Cloud Paks as well, starting with the IBM Cloud Pak for data management. This will provide clients with the IBM Cloud Pak for data management to have backup capabilities for data in the IBM Cloud Paks. As we continue to move forward and support more applications, there will be even tighter integration with the Cloud Pak for applications, and as we have richer functionality, we will be able to support deeper data reuse use cases for containers. Again, my name is Steve Kenniston, and I want to thank you for your time for listening to this presentation on IBM Data Protection for Containers. If you have any questions at all, please do not hesitate to reach out.